You're going to have to bear with me at the beginning. We have lots of vocab. Okay, I want to make sure that we get you all on the same page. So, we're still in vocab. Okay, the first thing is a ray. A ray is a part of a line. It has an end point, and then it extends infinitely in another direction, meaning it has an arrow. So one of the ends is an end point, and the other end is an arrow. We also have something called a vertex. We have used the word vertex in pretty much all of your math classes. In this case, we're going to say that the vertex is that point that's on a ray. So it's the starting point on a ray. Okay, so right here in this picture, you can see labeled B is the vertex. So the vertex is that point. We have our ray that extends. Okay. Then we have an angle. Okay, the definition of an angle when it comes to something tangible is two rays drawn from the same vertex. So they have that same point, and then they are drawn and they go infinitely in another direction. That is what creates an angle. Bless you. Okay, the next two. We have initial sides of angles. Initial. And that is just basically your starting side of your angle. And then you have something called the terminal side, which is the ending side of your angle. So initial is the first side of your angle. Terminal is the second. Anybody else still need that up there? Okay, wonderful. Okay, when we have an angle that is in standard position, I'm just going to draw you a picture of this. Okay, so imagine your coordinate plane. Okay, it says an angle has a vertex at the origin. So right here's my vertex. Okay, and then the initial side is on the positive x-axis. So a standard position angle has the initial side right there, and then your terminal side would be somewhere over on the left-hand side. So it could be right there, okay, or it could be further. So that's a standard position angle. If an angle is positive, it starts here at the standard position and it goes up. So when we draw it counterclockwise. Okay, if an angle is negative, it's an angle that's drawn clockwise. So we start here at our initial side, and we go down or we go clockwise. Okay, are there any questions so far? And this is kind of the boring part, but very good. All right. Next is degree. Okay, the word degree is the measurement that we use to show the rotation of the initial side. Okay, how we measure it, right? 45 degrees, 90 degrees. negative 123 degrees. There's a lot of different ways that we say it, but it's how we measure an angle. Does anybody know the other unit of measurement other than degree that we can have for an angle? Yeah, what's it called? Has pi in it. Say it again. Radians. You might need to write this one in somewhere. Find a little spot. Okay. It's another unit of measurement. The only thing that you need to remember right now is that it has pi in it. Okay. If I give you a measurement of an angle and it's maybe 3 pi over 4, that is given to you in the measurement of radians. If I say 45 degrees, I'm giving you it in degrees. Okay. So I'll either read it as, 3 pi over 4 radians, or I'll read it as 37 degrees, whatever I'm saying. So those are the two different units of measurement. Okay, let's put this whole on. All right, we'll do Greek letters here in just a second. But we know a right angle. Okay, a right angle forms 90 degrees. Okay, we can also say that that's 1/4 of a revolution. We're going to talk about revolutions here in a minute. If we have a straight angle, it's 180 degrees or half a revolution. And you can remember a straight angle because it looks like a horizon. Okay, it's just a straight line, and that whole angle is 180 degrees. Okay, so if you do this or not, the reason that a circle is 360 degrees is because a counterclockwise turn rotation 360 degrees is due to the Babylonian year, which is 360 days. So that's history for it. All right, let's do, I'm going to show you some Greek letters. Some of you may already know them. That's great. If we do alpha, it's kind of like A, but it has an extension on it. It's kind of like an A with a little bit of an extension. Beta is basically a capital B, but it has an extra stick at the bottom. Gamma looks like a Y with a twist. So when you draw it, it looks like that. A little twist at the bottom. And then theta is our most common. That one's the O with the line through it. And the reason that we talk about Greek letters when we talk about angles is because typically angles are written in with a Greek letter. We will use theta a lot today. I don't know if we use these as much, but we'll definitely use theta for sure. Any questions for me? All right, let's get into the fun stuff. So we're gonna kind of walk through what's a revolution. Is our angle positive or negative? How do we draw angles? So when you draw an angle, the first thing I want you to do is to just draw a coordinate plane, so your x and your y axis. Okay, raise your hand if you have worked with the unit circle in a previous math class. Sadly. If you have, you'll probably be a little bit more in tune to drawing these angles and know where they're located. Just as a heads up, we start with 0 degrees over on the right-hand side, okay? I need you to watch me here, okay? As we go around, we increase, and we come all the way back to 360 degrees. So we'll start at 0, do a first full circle, come to 360. You with me on that? Yes. Okay, so what would be this straight up and down right here? 90, 180, 270. You with me?
Yes.
Okay. So if we wanted to draw 45 degrees, okay, we have our initial side here. And then our terminal side, 45 degrees, is about right there. So that's how we would draw that angle. There's our 45-degree angle. Okay, you can kind of think 45 is half of 90. It should be halfway between the first x-axis there and that y-axis. Okay, so we did number 1. It says determine if the angle is positive or negative. Is it positive or negative angle? Positive. think about it, right? We had our initial side here, comes all the way up to the terminal side, it went up, so it was positive. Okay, and the last thing is tell me how many revolutions it is. So a revolution is 1 degree, okay? Or 1 over 360. So since this is 45 degrees, we would write it as 45 over 360. And then we would simplify that fraction. You can use your calculator to simplify that. Okay, and it should be, I think, 1/8. Is that right? 1/8. So we would say that it's 1/8 of a revolution. Okay, you went 1 out of 8 sections around the full circle. If you want to think about it that way. Questions for me? All right, let's keep rolling. All right, negative 90 degrees. We're going to go ahead and draw our angle. So draw that coordinate plane. Remember, I'm starting here at 0. Okay, show me with your arm, where would negative 90 degrees be? It would be down, right? So we have our initial side. Okay, and then here's our terminal side. I'm just going to go ahead and label it so we kind of know. That's negative 90 degrees. What is the positive version of negative 90 degrees? Think about it. If I went 0, 90, 180, what is this? 270, right? Now, it's not the same angle, okay, because we're talking about this angle. 270 would be this angle here, but you can kind of think about it in terms of positive. All right, was this positive or negative? It was definitely negative. When we drew the angle, we went down, right? We went counterclockwise. And then if you want to do revolutions, it's negative 90 over 360. Now, we can talk about, do we include the negative, do we not include the negative? It's fine, I don't care either way. But if I break down 90 over 360, I get 140. I kind of tend to think that, why do we leave the negative? There's not really something as like a negative revolution, because you're still going 1/4 of a circle, a full circle. So if you just tell me 1/4 of a revolution or negative 1/4, I'm not going to see it off either way. This is 1/4 of a revolution. Go ahead and see if you can set up the next one. Do all 3 parts. Draw the angle. Okay, tell me is it positive or negative, and then do those revolutions. Do your best on drawing that angle. Think about what you know. Okay, it should be somewhere close to where I drew my angle, and we're not getting real technical here with the 225 and it being perfectly over here. But that's roughly what it should look like. Definitely positive because it went up. And then if you reduce that fraction, it should be 5/8 revolutions. Questions, issues, concerns? Okay. Last one of these, and we're going to get to kind of the meat of why we're doing all this stuff. So go ahead and draw that circle. Okay, now this one may be, if you're not used to the unit circle, this may be kind of like, oh, what's going on? So it's 405 degrees. Okay, how many more degrees is that than 360? 45 degrees. So would you agree with me that we have our terminal side here? We're going to do a full revolution plus another 45. So really it would be like that. So we started here at our terminal side, went all the way around plus another 45. Any issues? Okay. Was it positive or negative? Positive. Okay, when you do your revolution, it's still the same thing. Okay, 405 divided by 360. I believe, correct me if I'm wrong, it should be 9/8. Okay, so it's 1 and 1/8 revolution, which makes sense, right? It should be an improper fraction.
If we wrote that down, would that be okay?
Yeah, if you wrote 1 and 1/8, that's great. Yep, that's totally fine. All right, questions before we move on? All right, our meat of this lesson is to find the arc length of a sector of a circle and to find the area of a sector of a circle. So let me kind of break down before we begin, what is arc length? Okay, so if you look at the circle that you have there, this part labeled S right here, that is an arc. And so what these next formulas help us do is they help us find the length of that arc. Okay, there's a lot of ways this can be used in real life. Okay, but for right now, let's just simplify it and think of a pizza. Okay, just think of a slice of pizza. We're going to find the length of a crust of a pizza. Okay, no, it sounds kind of silly, but that's kind of like, you just break it down easy like that. So if you would, in this particular example, you already have the radians equation written on your paper. Right under this radian equation, I need you to write the degree equation. I'm going to scroll up here for my friends who need me to scroll up. Okay, this is if you're given degrees. So go ahead and write that right below the S equals R theta. Go ahead and write this guy right here. Okay, and right beside this new one, write degrees, or you can put like D or whatever you want to do to note that it's degrees. Okay. Now the reason I'm giving you an extra formula, it simplifies things. Okay? If I give you an angle in degrees, you're going to use this formula. If I give you an angle in radians, for example, 3 pi over 4, you would use this formula. You with me on that? Okay, so let's go ahead and do this first one. I'm going to break down what each letter is for you. S is just the arc length. We use S to note arc length. R is the measurement of the radius that you're given. And theta is your angle. Now you're going to notice theta is in our degree equation and it's in our radian equation. So depending on what you're given, you have to choose which formula. Okay, so find the length of the arc of the circle of radius 2 meters, I hate that word, by a central angle of 63 degrees. I've never been able to say that word. Okay, so which one am I going to be using? Radian or degree formula? Degree, because I'm given 63 degrees. If I gave you radians, you would have to use the radian formula. But in this example, we're going to use this guy right here. Okay, so I'm going to plug in my radius, which is 2. Theta, which is what? What's my theta? 63. And then my formula has the pi over 180. And so at this point, your math period should be able to do that in your head. In our heads. First period is not even one. I was like, come on, tough crowd. No, you don't need to do it in your head. Put it in your calculator. I'm going to show you how to put it in your calculator, okay? I put it in exactly how I have it written, okay? 2 times 63. Hello, we're live. All right, and then our pi over 180. So exactly how I have it written on my paper is how I'm putting it into my calculator. I get 2.199. Raise your hand if you did not get 2.1. You did not get that?
I did it in my head though. So.
Okay, if you sit in your calculator, you're doing it that way.
Why?
Okay, so let's go ahead and round to 2.2. Okay, now I am going to be stickler on measurements. Okay, your measurements need to be reflective of what your question was. So if I'm talking about the length of a crust of a pizza, am I going to measure that in degrees? Probably not, right? I'm more like inches or centimeters or meters or whatever I'm given, right? So here, since the radius was in meters, your arc length is also in meters. Okay, so the arc length of that is 2.2. All right, would you like to do a radian example together?
Yes.
Okay, go ahead and flip to the next page. So just flip over your packet. We'll come back in a second. Okay, go ahead and go to number, the front page there, I think it's number 3. Okay, see how number 3 is different than number 1 in the fact that the measure of the angle? And number 1, it's 315 degrees. And number 3, it's 3 pi over 2. Do you see the difference? Okay, what am I using for number 3? Read it to me. You can look over your paper and look at it. R theta. Okay, that's the radian formula. So when you are given radians, you have to use R theta. So in this case, our R is 16, and our angle is 3 pi over 2. Yes. So this is radians, this is not degrees. Okay, so we talked at the beginning of the lesson how radians have pi in them. So if you see pi at all, you're going to assume it's radians. Number 4 would be radians, number 1 would be degrees. Right? Yeah, so if you see pi, that's radians. Okay, great, good question. All right, so now we're going to put this in our calculator. I'll just do it right here. Yeah, I'm getting 75, we'll say 75.4. Okay, now, what is my measurement that I put on that? Remember, you're doing arc length. We literally just found this arc length right here. Feet. Okay, you have to use the question to help you get that. Okay. All right, let's go back to our notes. That is arc length. Let's talk about the sector area. Okay, so what we just said is we found the length of our crust. Now what we're going to do is we're going to find how big is our piece of pizza. What's the area of our piece of pizza? So if you look here, okay, what we're doing is we're taking a section and we're finding the area of that whole section now. With me?
Yeah.
Okay. So our last thing for today, so stick with me. Again, you are going to have a degree formula and a radian formula. So under your radian formula somewhere, go ahead and write your degree formula. You're going to need both. Okay, you're already given the radian formula. You need to write the degree formula somewhere on your paper so that you have that.
I remember. I wasn't.
All right. So look at our question. It says find the area of the sector of a circle of radius 2 feet formed by an angle of 30 degrees. Which formula am I going to use? Radian or degree formula? What am I given? Degrees. So I'm going to use degree formula. Oops, I forgot to put in my theta. Oopsie. What am I plugging in for theta? What's my angle? 30. What's my radius? 2. Again, you should be able to do it in your head by now. I'm totally kidding. Put it in your calculator.
You get me the number really good.
It's not really money, so listen up. Okay, you should get about 1.05 if you round properly. What is my measurement? Think back to feet, but feet what? If we're talking about area, area is always measured in square something. So if somebody measures the area of your house, okay, it's going to be in square feet. Okay, so. Did you say what? Okay. All right. So, do you guys want to do a radian version? We're doing it anyway. Okay. So, go ahead to the very back. A very back page. Okay. Take a look at number 13. Stay with me. Stay with me. We're almost there. Okay, number 13, which formula are you going to use for number 13? Degree. Because it's 60 degrees. For number 15, what are you going to use? Radian formula. Okay, so let's go ahead and write it down. So radian formula is 1/2 r squared theta. Okay, so for my r, I plug in 4 because that's the radius. For my theta, I plug in 3 pi over 2. And again, we just put it in our calculator the way that it's written on the board. Parentheses are your best friend. Yeah.
Okay. The theta is the one that's inside.
Theta is your angle. So your angle will either be in degrees or it'll be in radians. What's your what?
You know,
Yeah. Okay, and it's whatever your radius is will be the other method. That'll be so your radius is found in the inverse. Okay. All right. So you should get 37. We'll say 37.7. Group. Last question of the day. What is the measurement or the label on my answer? Centimeters squared. Centimeters squared. All right, I want you to work on those practice problems. The very back is area. Are you listening? Because we had issues reading directions. The very back says find the area of the sector. The very front of the practice is all arc length. Okay? So there's 1 and 1. I have people from first period using the area equation on the front page, so don't do that. All right, go ahead and work.